rational inequalities. We do it very similar for rational inequalities, but there's one more additional step. My boundaries are not only my zeros, but also my vertical asymptotes. So I have to find both the zeros and my vertical asymptotes. Those are my boundaries. So remember we did the graphical example. That's the first question we asked. When is it zero and what is its asymptote? I don't need my horizontal asymptotes, so I'm only going to find vertical. Verticals are the only one that are my boundaries. Right? Because I can't exist at my vertical asymptotes. And so between my vertical asymptotes and between my zeros are where my function either is positive or negative. Right? And again, I'm going to do a similar thing here. I'm going to set it up with the graph and the table, just to make sure. The table's kind of just to double check that I'm doing my graph part right. Alright, first thing though is that I set it equals 0, so I'm going to move that 3/4 to the other side. So I'm going to subtract it by moving it over. And so I'm going to get 1 over x minus 1 plus 1 over x plus 1 minus 3/4 greater than 0. Alright, and so my first thing is to find my zeros and my vertical asymptotes. And again, my zeros are a little tougher, but I can find my vertical asymptotes. What's going to cause me to divide by 0? Well, my x minus 1, my x plus 1 are my division parts, right? And so my vertical asymptotes are at 1 and negative 1, so I know those are boundaries. So it doesn't exist at 1 and negative 1, and I should have asymptotes in those cases. Alright, then I still need to find my 0, and I'm going to do that graphically. So I'm going to graph this, so make sure you're careful if you're graphing along with me. Make sure you put parentheses around your divisors. Alright, so if you graph this, the graph does reflect there is an asymptote at 1 and negative 1. There is a vertical, a break at 1 and negative 1. And then the shape of the graph, it comes down, it does cross here, and then it has this shape, kind of an S shape. And so there's a 0 that I need to find. And then it comes across again and has another 0 over here. Comes down. And then the last piece is up here. Alright, so it means there's a horizontal asymptote. I don't know what it is, but there is one. There's a horizontal asymptote. Alright, and I do have 2 zeros. So I have to find those. And again, you use your calculator to find them. So I'm going to go to left, right, guess. And so this 0 comes out 0.333333 forever. So remember, that's a third when it comes out 3 repeating. So negative 1/3 there. And that one comes out positive 3. Alright, so my zeros are at x equals negative 1/3 and positive 3, right? Negative 0.3333 continuous is negative 1/3. Which means those are my boundaries. I'm neither positive nor negative at any of those, right? I'm 0 at negative 1/3 and 3. I don't exist at 1 and negative 1. Everywhere else, though, it should be positive and negative. That's why I kind of set up my table. The table is just kind of to help you make sure you don't miss any of your parts. Alright, so I go through and I write out each piece. Right, so the first piece goes from negative infinity to first break. Well, my first break here is at negative 1. Alright, then I have a little break between negative 1 and negative 1/3. Between the negative 1 and my zeros. There's a break there. And then negative 1/3 to my next asymptote, which is at positive 1. So there's a little area there. And then positive 1 to my 0, 3. And then my 3 to infinity. So there's a whole lot of parts to this. So this is what the table is kind of organizing all of the places that my answer could show up. Making sure I don't miss anybody. Right? And so there are 5 pieces. Because there's a break between positives and negatives at my asymptotes and my zeros. So there's got to be a break between my asymptotes and my zeros. And so there's a break here at negative 1, there's a break here at this 0, there's a break here at positive 1, and then there's a break here at 3, which puts, there's all of these different pieces. Actually, I'm going to do different colors for positives and negatives. Redraw that. Alright, so I'm going to let my yellow be, so it's negative here, it's negative there, and it's negative there. Ugh. Negative there, and then I'm going to use blue So there are 5 different pieces that I've highlighted, right? 5 different pieces where the function breaks. So my blue pieces are where it's positive, my yellow pieces are where it's negative, and so I'm going to go fill that out over here. And so it's from negative infinity to negative 1, well that's this piece and it's negative. Right? So it's negative there. There's a small piece right between my negative 1 and my 3. That's this blue piece here. It's just a small piece. Well, that small piece is positive. And then there's this yellow piece where it's negative between negative 1/3 and positive 1. And then there's this small piece where it's positive again between 1 and 3. And then there's this yellow piece where it's negative between 3 to infinity. And so which case do I want? Well, I want the positive cases, right? And I don't want the zeros. So I only want the positives. And there's no zeros included, so I leave parentheses, no brackets. So my answer is from negative 1 to negative 1/3, parentheses, not brackets, make sure that looks like a parenthesis, or parentheses 1 to 3. And again, it's parentheses because I do not include the zeros, right? There's no equal to, it's just bigger than 0. And those are the only places where it's bigger. And so that's it. It's just these little small blue pieces where the answer is positive. Everywhere else, it either is 0, negative, or does not exist. All right, the second example. So this one's a little easier because it's already set up for me. I don't have to do any moving around, so all I have to do is graph this piece, and I want to find where it's less than or equal to 0. Alright, so again I need to find my zeros and my vertical asymptotes. VA, vertical asymptotes. So I'm going to go ahead and graph it. And so if you graph it, there actually are 2 asymptotes. Alright, there's a break. If I look at my graph on my calculator, it looks like it's at x equals negative 1 and x equals 2. Alright, then this piece is above here, and below there. And then there is, it's hard to tell, but it does cross the x-axis here. Alright, and this is where understanding how the graph works from our previous cases is helpful. If I look at this function, alright, and I write it out in it, so I'm going to write it below here. So I'm looking at the function that I've graphed, which was 5 minus x over x squared minus x minus 2. Alright, that's the function that I've graphed above. Alright, f of x has a 0 when the numerator is 0, right? When the numerator is 0, well, it's when the 5 minus x is 0, and so that's at 5. So I know it's got a 0 here at 5, which, again, you can find on your calculator. It's a little hard to see, so you might miss it if you're just looking at your calculator. That's why it's good to know. That's why we practiced graphing this in the last section, so we understand where things happen. So I know it's got a 0 at 5, and then where it's got asymptotes is where the bottom is 0, right? My asymptotes, my vertical asymptotes, are when the x squared minus x minus 2 equals 0. Well, I factor that. Well, that factors into the x minus 2, x plus 1. And so I do have an asymptote at 2, and I do have an asymptote at negative 1. So I'm kind of doing my scratch work over here to the side to check make sure my picture isn't easy to necessarily see those things from my graph plan, and it's really easy to miss the 0, right? Because this is so tight to the graph here. If you look on your calculator, it's hard to see that there is a 0 at 5, but I know there should be a 0 at 5 because I know the behavior of the function. Alright, so there's only one 0 at x equals 5. There are 2 asymptotes at x equals negative 1 and positive 2. That's what these are. So 2 and negative 1. And so those are my boundaries. So now I'm going to set up my table so I don't miss anybody. Alright, so my intervals, and then my test. Alright, so my first interval is negative infinity to my first boundary at negative 1, so negative infinity to my asymptote negative 1. My next boundary is between my asymptotes, right? This whole thing is between my asymptotes negative 1 and 2. My next boundary goes to my 2 and my 0 at 5, so 2 and 5. Which 5 is my 0, I've got to keep that in mind. And then my last boundary is from 5 to negative infinity. So 5 is a 0. Alright, now I test, which again I'm going to use highlights. So I'm going to highlight yellow is below, so yellow, this is all below here, and that piece is below. Blue is going to be above, this is above, and this is above. Alright, so there's 2 parts that are above, 2 parts that are below. So from negative infinity to negative 1, that's the blue part, that's positive. Negative 1 to 2, that's negative. 2 to 5, positive. 5 to infinity, negative. Alright, now what do I want as my final answer? Well, I want everything that is both less than or equal to 0. So I've got to remember this is my 0. It's going to be a part of my answer. So I want all of the negative parts, and that's the yellow parts, and the zeros. And so my answer is this, but then don't forget to include the 0. It's really easy to forget that. So make sure you double check the equal to. So my answer is negative 1 to 2. There's no 0 there. Those are both asymptotes. Or 5 to infinity. But remember, 5 is the 0, so I get to include 5. So it's brackets on the 5. And the zeros are the hard part. When I include 0, I've got to make sure I include the 0 and use a bracket in my answer. So the answer to this function is negative between my asymptotes, negative 1 and 2. And for my 0, 5 to infinity. And so since I get to include 0, I get to include the 5. Alright, so that finishes up solving inequalities. And the last thing we're going to do from this chapter is look at a few applications of inequalities and then a couple variation examples, which we've talked about again before. And I'm going to introduce them again here in